So hello again, this is about an old project of mine. So if you remember a few days ago, I was so proud, about having this stand finally up. I've been working one day, I'm not good with carpentries and stuff like that. But anyway, it's up and it's working and my panels are safe up on the roof doing what they're supposed to do, capturing solar power and get the sunshine into my house, okay? But in the meantime, I observed something interesting. What? One of the photos I took before, look there. 1261 watts. And not only this one, I can tell you that I was reaching more than 1300, almost 1.4 kilowatts of power. But not anymore. So I was really concerned about what's happening. What's wrong with this guy? What's wrong with my setup? Today, I took everything apart and I reconnect everything and I found something very interesting. So, in fact, it's my mistake. I shouldn't listen to some others, like I'm always doing my own researching and my own tests. But this time I was just, following words. Let's call it words, or I better call it folklore, So, you see, these panels here, 1, 2, 3, they're kind of different, okay? Let's have these guys exactly like I have it on the stand. So I got 1, 2, 3, okay? Okay, so these are the panels I'm talking about, 180 watts. What we are looking here, it's the maximum power voltage. That's what we are looking for. So this is a 22 volts for each of them, okay? So let's say this is the first row, then I have another two and another two of 150 watts. This kind of panels, let me see. I got them here and these panels have 18.4 VMP. So, like I said, that's what we are looking for. 150, 18.8. Then I have a big one, 72 cells. In fact, it's like two of these in a single panel. This guy here, which is like 38.8 volts VMP, and then another two, same like this, 100 watts with 18.4. Okay, you can see here the current, it's almost the same. Okay, this one have a little higher current, like 9 amps. We are looking at current P max, this one here, IMP. 9 IM, that's the most important thing, VMP and IMP. Okay, these ones have like 8.16 IMP, and the other guys, they have like, where is that? IMP 8.1. So these guys are almost 8.1 amps IM and P. Okay, somehow like the amps, these guys are almost the same with this. I put the things together one by one, so I didn't have enough money to buy 10 panels same. So I just put them and could afford them, because I called these guys and they said, solar farm, by the way, they are very nice, small size, very powerful. Okay, and they said, there's no problem, you just hook them with the rest of the things. And I did a very simple something like this, let's call it minus, goes to minus here, plus evidently, and then we have another connection here, plus to minus, and finally we have plus. All right, minus here and plus. Absolutely 66 volts VMP. Like I said before, that's all it matters, voltage under load. Then I said, okay, these guys are pretty similar, so let me have a plus from here going to a minus here, all right? And then I have a minus here and a plus from here. And it's like 38 plus, very simple to deduct, 38.8 plus 18.4, 57.2 volts. And the other guys, almost the same. Let's have a minus here, then together, plus, all right, minus, sorry, plus here, plus there. These guys Oh no, sorry, this one goes to minus here, minus, and of course plus from the row number 3, let's call it number 3, number 2, and number 1. And here we have almost the same, like 18.4 times 3, 55. Said to myself, it shouldn't be a big deal. 57, 55, almost there. You know, numbers are just numbers. In the field, it's another situation. But doing some, cosmetic wiring, getting the wires together and put them in a certain way along the path behind the things here. When I use my clamp meter, I realize, okay, these two guys here, like this and this one, right? Minus, and then plus here. It was no problem, no difference at all. So we had here like same story, 57 volts. Obviously the amps together and the power together and so on. This is fine. All right. But when I connected or checking, in fact, this arm, this plus here, going here, of course, the minus going here. On this arm, I found a 4.5 amps leakage, or I don't know how to call it. Okay, I disconnect everything. I disconnect the inverter, put all the things in the air. I said, what's happening? There is no load. And the path was clearly in the air, but of course connected in parallel. So 1 and 2, first row, number 2 cell, and number 3 here. Okay? These guys, they've been a family, a group. All right? These guys, and of course this one, another group, and these guys group. All right, so I found 4.5, and it wasn't in the midday, it was in the afternoon around 3 o'clock. The sun was pretty out of the way, like almost in the video on the screen. And then I realized, in fact, these panels, they've been losing power on the other guys. This one was a load for these panels. Crazy. And the point is, that was exactly the difference between, let's say, today I had like 1025 watts, something like this, and usually I could get around 1350 watts. And you see, 325 watts of wasted energy, which was exactly, loading or feeding the extra or the higher voltage one to the low voltage, which, by the way, they are pretty similar, let's say, 2 volts difference, okay? So here, because of this difference of potential, difference of voltage, in fact, I was not pushing current to the inverter, but a part of this current was going into the other cells or the diodes or everything inside there. So guys, I was really pissed about doing something without checking and just listening because, oh, no problem, just put them in series and parallel and everything will be all right. And this is a typical seller kind of answer, don't worry, it's working. Doesn't matter if this one it's 10 amps, the other one are 5 amps, just put them in series. What? If you put 10 amps panel with a 5 one in series, of course the current will be only 5 amps because the smallest one is the leading current, let's say. So what I had to do all day long, I couldn't find any solution but to do like that. I took 22 volt panel, I connect that with 18.4. The current is the same. That was my first cell or row of cells, okay? This is minus, 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 plus, plus, plus. Here we have 58.8 VMP. I wish to go higher like that because my inverter, it can work at maximum 90, because my inverter can work at 90 volts, but I couldn't find any other way to get the right voltages, so I am stuck with 60 volts all around. Okay, so this was the first row of cells. Then I had the big one, 38.8 volts with a 22. Well, here is a little problem because this one is like 9 amps, the other one is like 8 amps. So somehow I'm losing 1 amp. What can I do? That's it. Okay, and then I have another 2 18s, similar like the first, and another 22. Somehow I split the cells and I have to each group of panels at 22 volts in series. So I spread it, the 22 ones around. Okay, and the single difference here, of course, 57 MP maximum, 8.8 plus 2. But funny, when I put all the things together, of course, I started with this minus, get them together, minus, general minus, let's call it, and of course, then the plus, okay? And I had the voltage, there was no problem. So I measured here, few milliamps, 0.010 or something between these guys, so it was absolutely okay. Then I add this guy to the main, or to the main feed line, let's call it. And here I had like 0.0, I don't know, maybe 40 milliamps. But like I said, it was in the afternoon, so not so much power. But anyway, the voltages now are pretty close and pretty balanced. The single problem here, panel which have 9 amps instead of 8, so somehow I'm losing some power here. But I bet the things are getting, through the diodes and all the other stuffs in the panels, it's not such a loss. The final lesson is never listen to sellers, never listen to recipes. Do test and think, which I'm usually doing. But this time I was in a hurry, Doing that stand was really overwhelming me with constructing rush, let's call it. Because it's a rush, You must have fun if you are doing things like this. I'll see in the next days if my theory is correct and if I get again those 200, 300 watts, which doesn't seem much, but if you take it like 5-6 hours per day, it's like almost 2 kilowatts, 1.5 something. And with the prices for electricity today, it really matters. And if you are following this, you see the voltages are here. All that matters is the voltages for me now, because the current is pretty similar. Tell me if you can find another way to put these panels together and to have somewhere between 60 to maximum 90 volts VMP. This is important. We don't care about the open circuit voltage, 46 volts. We don't care about this. The real one, what matters is this one, the VMP voltage of Pmax. This is very important. Okay? Like I said before, like, subscribe, and don't forget to write, and of course, have fun. I'm having. Okay, bye.